In this video we are going to go over some problems from the textbook that we use in our class, which is from Glencoe's Advanced Mathematical Concepts. I think this is the 2004 version, and it's on the law of sines, which is section 8.6. So let's look at these problems. So we have this landscaping problem. It says that a landscaper wants to plant begonias along the edges of a triangular plot of ground. So I'm going to sketch a triangle and represent the information. The triangle does not have to be to scale. Let's see, two of the angles are 95 and 40. And the side between these angles is 80 feet long. So now if these two angles are 95 and 40 by triangle sums, I can easily figure out the other angle. They add up to 135 degrees, so 135 from 180 gives me 45. So that angle is 45 degrees. I have an angle with its opposite side. They want me to find the measure of the third angle, which we did, that was 45. And find the length of the other two sides. So this is set up for the law of sines. And we'll call this vertex A, B, C, which means they want us to find side A, and they also want us to find side B. They're giving us side C. Find the length of the other two sides. So what we need to do is, if we go for A first, the sine of 45 over 80 is equal to the sine of 95 over lowercase a. A is going to be 80 sine 95 divided by sine 45. Okay, set up the ratio for side B. So 40 and B go together, and 45 and 80 go together. So sine 45 over 80 is equal to sine of 40 over B. So B is going to be 80 times the sine of 40 divided by sine 45. Let's see, what does it say about rounding? It doesn't say anything about rounding, so I'm going to probably round to 1 decimal place. So let's see, to find A, 80 times the sine of 45, 80 times sine of 45 equals, divided by the, I think I did that one wrong. So scratch that. We're going to do 80 times the sine of 95. So 80 times 95 sine equals, divided by the sine of 45. 45 sine equals, comes to be 112.7. So A is 112.7. And we're in feet. And let's find B. So B is going to be 80 times the sine of 40. So 80 times 40 sine equals, divided by sine of 45, divided by 45 sine equals, comes out to be 72.7 feet. So that's what we got for B. Got those two sides there. What's the perimeter of this plot of land? We want to add the 72.7 plus 112.7 plus 80 to get the perimeter, which is the distance around, like a fence around, and we get 265.4. So 265.4 feet is the perimeter. Okay, so that's it for that one. Let's look at number 30. Now number 30 wants us to find the area of the courtyard, and they give some information about a regular pentagon. So an area formula that comes from this section. Let me bring that up and review that real quickly here. The area formulas that we have for a triangle are our basic one that we know, area is 1/2 base times height, and which depends on being able to find the altitude. We have two other area formulas. We have Hero or Heron's formula. If you know the three sides, it's the square root of the semi-perimeter, which is the sum of the sides divided by 2, times the difference of the semi-perimeter in each one of the sides. You take the square root, and that gives you a way of finding the area of the triangle. And then we have an SA side angle side version where we are looking at, and there's really 3 different versions of these with, you know, the letters in the different places, but basically what you're talking about is an angle that hinges 2 sides together. The sine of that angle times the product of those 2 sides times 1/2 gives you the area of the triangle, and it works for all triangles. So we don't really need to learn all 3 formulas. We just really need to know the pattern, side angle side, the 2 sides times the sine of the angle. So that's what we'll have to bring to bear as we do this problem. So let's look. It says that this, the Pentagon has a courtyard in the shape of a regular pentagon. So I'm going to sketch a pentagon. I'll label it as being regular. And it tells us that this pentagon could be inscribed in a circle. Now, an inscribed circle goes through the vertices. So, in other words, there's a circle that can be drawn or circumscribed about the pentagon. The pentagon is inscribed in the circle. And it's telling us that this circle radius is 300 feet. So each one of these arms or spokes is 300 feet. Since this is a regular hexagon, each one of these triangles is congruent, and each one of these angles is congruent. We have 5 angles that all together make up a circle. So if we divide 360 by 5, we get 72 degrees. So each one of these central angles is 72 degrees. So if I just kind of sketch a version of the triangle, we've got a 72 degree angle there, and each one of these sides is a 300. Overboard on that one, because for this one all we really need to do is find the area of one of those triangles, and then we're going to multiply by 5 because the total area is going to be 5 of those. So we're going to use K equals 1/2 AB sine theta, and A is 300, B is 300, and the angle between those is a 72. So we have sine 72 times 1/2. So that's going to give us one triangle, and from the regular pentagon we actually have 5 of those congruent triangles. So we're going to multiply our answer by 5. So bring the calculator in, 0.5 times 300 times 300 times sine of 72, 72 sine equals 42,797.5. 42,797.5. And this is feet squared. So one triangle has an area of almost 43,000 square feet. If we want to know what the inside area of the courtyard is, we need to multiply that by 5. So do times 5 equals, and we get 213,987.7. So the total area is 213,988 feet squared. let's look at number 34. 34 is a little bit of a tricky problem here. So this architect is designing an overhang, and he doesn't want the sun to hit the door, the sliding door here. And the angle of elevation, so I guess this has to do with the angle of elevation of the sun being 63 degrees. So what do they want us to find? They want us to find how long should the architect make the overhang. They want us to find this distance right there. So I can see that if I do alternate interior angles, if this is a 63 degree angle, that's a 63 degree angle. So I could actually do this. I've got the opposite side that I need to find. I need to find out what this angle is. If I do 180 and subtract 55 and 63, I'm subtracting 118 from 180, and I get 62 degrees. So this is going to be 62 degrees. So I don't know what this distance here is. This is what I need to find. Call this x. What else could we do here? If I could find this side or this side, I could use the law of sines. So let's see what it would take to find that top side up here. If I draw back a little bit and look at this triangle here, I can see that this is a side of the triangle. They're telling me that this is a 63 degree angle, and that I can see that this is perpendicular, so that's going to cause this angle to be 27 degrees, because those two angles have to be complements of each other. And they're telling me that this side of the triangle is a 13, so if I sketch this triangle off to the side, I've got a 13, I've got a 27, and I need to find that opposite side. I'll call that a y. And so if I look at what I have here, I have an opposite side. Here's the hypotenuse. So I have an opposite with an adjacent set of active sides. This is a tangent ratio problem to find y. So I can say tan 27 is equal to opposite, which is y, over 13, or 13 times the tangent of 27 is equal to y. So let's see what that distance is. We've got 13 tan 27. 13 times 27 tangent equals 6.62, so we'll call that 6.6. So y is equal to 6.6 feet. It's this distance up here. Okay, now we've got enough to finish the problem. If we take the top triangle, we'll sketch it down here. This is a 62, this is a 55, and this is a 63. And this is a 6.6, and this is what they want us to find. So I can see that we have an angle and its opposite side that we calculated, and we can use the law of sines to figure out what we need to for that one. So let's see, sine of 62 over 6.6, bring in like another decimal, 6.62 is equal to, doesn't really matter I don't think, is equal to sine of 63 over x. We're going to cross multiply and simplify. X is going to be 6.62 sine 63 divided by sine 62. So 6.62 times sine of 63 equals, divided by 62 sine equals, comes out to be 6.68. See what they need for the accuracy, just how long should he make it? So he should make it, say, 6.7 feet long. If you need to visualize what 0.7 feet is, you could do 0.7 times 12. and it's like almost 8.5 inches. So about a little bit more than 6 feet 8 inches is how long this overhang needs to be to block the sun. Okay, so we've got that one. Let's look at this balloon problem real quick, and we'll just set it up and not bother solving it. I'll let you finish that up. I notice here that they're giving us degree minute seconds and degree minute seconds. So it's easier, I think, to convert these to decimal degrees and not have to worry about using extra keystrokes on the calculator. So 20 and 15/60ths comes out to be 20.25 decimal degrees, and 62 and 30/60ths comes out to be 62.5 degrees. Okay, so I've got those taken care of. Let's see, so the balloonist is flying over to the left side of the balloon, which is to the right side of our picture. So if we got the balloon to the left of the balloon, the angle of depression is 62.5 degrees, and to the other side of the balloon, the angle of depression is 20.25 degrees. And we know that these are 4 miles apart. So they want us to find the distance from the balloon to the soccer fields. So from the balloon to the soccer fields is this direction here. And what's the distance to the football field? So we got the soccer field, and we got the football field. And it wants us to find this distance here also. So let's see what we can do there. We need to find this angle opposite this, and then we need to also find what these other two angles are. By alternate interior angles, this is a 20.25 degree angle. By alternate interior angles, this is a 62.5 degree angle. I could have done supplementary and added all these up and made them equal to 180. But if I add the 62.5 and the 20.25, 62.5 plus 20.25, I get 82.75. I want to find the difference of that and 180. Comes out to be 97.25. So this top angle here is 97.25. I've got an angle on its opposite side. I need to find this ratio, this angle with its opposite side, which is to the football field, and this one to the opposite side, which is to the soccer field. So that problem is set up enough where you can apply the law of sines. Sine of 97.25 over 4 is equal to sine of 20.25 over, say, x, and that's also equal to sine of 62.5, say, over y. And you can finish it and find x and y. And it doesn't say anything about the distances or rounding. We're dealing with 4 miles here, so I would think you could probably just go for integer type distances, or maybe 1 decimal place. Okay, that's it for these. Let me know if you have any questions.